To look at matrices. Basic concept. A matrix is a rectangular array of numbers that are enclosed within brackets. So when you have a rectangular array of numbers arranged in an enclosed bracket like this, we call it a matrix. It's a matrix. Look at this. It's a matrix. It's a matrix. All of them are matrices. So now take 2, 3, minus 5, 1. This matrix, for example, the numbers 2, 3, minus 5, 1 are called elements of the matrix. So all the number contained in this particular bracket, they are called the element of matrix. The matrix 2, 3, minus 5, and 1, it has 2 rows and 2 columns of elements, and it is said to have order of 2 by 2. Read 2 by 2. Okay, so now if you look at this matrix, this is row, 2 and 3 are row. Look at the cursor. This is a row, this is column, this is column. Okay, first row, second row, then first column, then second column. So since it has 2 row and 2 column, we call it 2 by 2, 2 by 2 matrix. This is the first row, the second row is the first column, is the second column. So in general, a matrix with m row and n columns is said to have order of m by n. This sign of times is by. Okay, so m represent the row, n represent the column. Okay, so row matrix. When do we say a matrix is a row matrix? Is a matrix with only one row of elements. It's a matrix with only one row of elements. Look at this. We have rows, one row only one row, and is 1 by 3 matrix. 1 by 3 matrix. Why? Because the row is 1, the column is 3. The column is 3, but the row is 1. So column matrix is a matrix with only one column and is also called 3 by 1 order matrix. E.g., you see we have, this is row 1, row 2, row 3, but you discover that the column is 1, the column is 1. So therefore it's 3 by 1. Remember, the first value represents row, the second value represents column. This shows that the column is, the row is 3, then the number of column is 1. Okay, so let's look at the denotations. Okay, a matrix is denoted by a bold-faced capital letter. Okay, we don't use small letter to denote a matrix. Why the elements of the matrix are denoted by small letter with subscripts, which uniquely define the exact positions of each element in the array. So a small letter is what we use to represent elements of matrix, while the matrix itself is, we use capital letter. Okay, so e.g., this is A, matrix A. This one we call it matrix A. It's capital letter, equals to, look at this matrix, A11, A12, with subscript attached to them. This subscript helps us to know the exact location of the element in this matrix. Okay, so element in first row and first column. So this 1, 1, the first one represent column. So this element is in the column. Okay, the first, represent the row, the first one represent the row rather. So this A is in first row, and you see that the A2 is in first column. So therefore that is why we have A11. If you go to A22, you show that this element is in second column. All right, in second row and in second column, second row and in second column. Okay, so this, look at it, element in second column and second row. So these are the denotations. So in general, the element A subscript I, J is an element of matrix in ith row and jth row. Okay, so example, now let's look at example. We have what we have here is example 1. If A is equals to minus 1, 3, and all of this, and this is a 3 by 3 matrix, okay, 3 by 3 order matrix. So find A 2 1, A 2 3, A 3 2, A 3 3. Okay, so what is A21 representing? Remember, this is element. This is telling us to find A. The small letter is telling us the element. The subscript 21 is telling us the position. So this first two is row. It means this particular element is in row 2 and then it's in column 1. So first of all, this is the first row, this is the second row, then this is the last row. So we are looking for, if you want to look for this element now, we have to come to row 2. Why is it in row 2? Because the first subscript number here is 2, then the column is column 1. So row 2 is here, the first column, this is the first column, so these two fall in the answer. This is our answer, these two. All right, this two is our answer. Why? Because it's in the second row and then it's in the first column. Okay, so A23, A23, that means element in second row and in third column. Element in second row and in third column. This is the third column, which is 4. Okay, A232, this is element in third row and then second column. Element in third row, this is the third row, this is the third row, and then in second column, this is -6. Second column, third row, -6. So we have -6. So D, element in third row and third column. Third row and third column, 4 to 1. This is 1. So that is why we have 1 there. The next thing we want to discuss is equality of matrix. That thing is equality of matrix. So pardon that error. Equality of matrix. That is what is supposed to be there. Two matrices which have the same order are said to be equal if their corresponding elements are equal. So when a matrix is equal, matrix is only equal when their corresponding elements are equal. All right, but they have to be in the same order. Okay, for a matrix to be equal, it has to be in the same order, and then their corresponding element has to be, equal. So given that matrix A is equals to this and matrix B is equals to this, so this is a 2 by 2 order matrix, this is a 2 by 2 order matrix. So A is equals to B if and only if all the element of A is equal to the element of B. Now example, let's look at example. Given 2xy minus 4 equals to 2, 3, 1 minus 4. Find the value of x and y. This is equals to this. These two matrices, they are equal to themselves. Why? Because they have the same order, 2 by 2, 2 by 2 matrix, and the same number of elements here is the same here. So you see 1, 2, 3, 4, 4 elements, 1, 2, 3, 4, 4 elements. So if they are equal, what is the value of x and what is the value of y? Okay, so solution, since the two matrices are equal, their corresponding elements are equal. Hence, okay, so 2 is equal to 2 here. So x here will definitely be equal to 3. So that is why s is equals to 3. So you see -4 is equals to -4. So therefore y will be equals to 1. So you see y is 1.